All right, physicists. So let's take a look at this ranking task. We've got figures below showing hollow spheres not drawn to scale that are rolling at a constant rate without slipping. It says the spheres all have the same mass, but their radii, as well as their linear and angular speeds, vary. And it asks us to rank their rotational kinetic energy as they're moving. So in order to rank the kinetic energy, I think we probably need to know that the kinetic energy, the rotational kinetic energy, is 1/2 I omega squared. Okay, so we already know the omega value, so that's cool. We need to figure out what I is, right? So if we look back at our moments of inertia chart that we've been kind of referring to for the last little bit, it says that it's a hollow sphere, so that's going to be 2/3 mr squared. Now, just as I'm going back here, um, because they're all the same, the 2/3 doesn't matter. So, but I'm going to go ahead and write it in here just so that we've got it. So we've got 1/2, and then we've got 2/3. Oops, I'm having a hard time writing. Let me try that again. 2/3 mr squared times r omega squared. So the 1/2 is going to be the same for everything, and the 2/3 is going to be the same for everything. And it said that they have the same mass, so that means the mass is going to be the same. So really the only two things we care about are the radius and omega. Now, it doesn't tell us the radii, but we do know a relationship between r, v, and omega. And that relationship, just a friendly reminder, is, excuse me, that v is equal to omega r. I'm going to solve that for r today. We don't usually solve it for r, but we can, is equal to v over omega. So instead of writing r here, I'm going to go ahead and write v over omega. So when I'm trying to rank my rotational kinetic energy, I'm going to have v over omega squared times omega squared. Part of the reason I love doing these is because you can really see the relationships here, you guys. So we've got v squared over omega squared times omega squared. Hey, look, even the omega squared doesn't matter. The only thing that we really care about is ranking based on velocity, the translational velocity. So then we just need to look at the translational velocities. It looks like E and F have really big translational velocities. So E and F are going to be the greatest. We've got B and D that are next. And then it looks like C is greater than A. There you go.